So do any of you have any questions about the robot?
How long does it take to make?
6 weeks.
Well,
Oh,
we
4 weeks.
designed it in 4 weeks and we built it in 2 weeks.
But the entire process takes 6 weeks overall.
So if all the things that you were stacking were about that high, like how did it stack 6 of them?
We only have 2. They stack much higher. We only have 2 beds.
How do you stack it? Yeah. Well, we keep doing that, but we also usually just has hooks in here, but we keep them out because someone broke them. And those hooks would pick these up once Adam stack them, and the power moves up. That's how you get 6.
How much did it cost?
So this robot costs only a few $1,000s.
The budget is
Yeah. But the actual budget for competition is $4,000. To get into the competition, you need to pay $5,000. And then, what else do other expenses go? There's also
hotel.
yeah, hotels are each like 180. And then what else? So they also have workshops. Some teams use workshops that can cost us like $80,000 a year. So yeah.
We use dope.
Where did you get your materials?
So we bought all the materials. The electronics are the only ones we bought like pre-made, but all the rest we just bought the basic supplies and made it ourselves. For example, chassis we cut out sheet metal, like at the Dell workshop, and we cut it out and shaped it all ourselves.
You have a question?
Okay, so volunteers. How much weight can they? I'll get back to that. But
and what we do is we make these printouts, and we then glue on top of that. We cut out the pieces into like a blob, like a circle for a giant piece, and we cut the details out, and then we would take off the paper and set it
So he asked a good question. How much of the lift? So this claw right here lifts about 12 pounds. This lifts about 20, but the actual robot itself can carry a total of something over 120 pounds.
It can hold, like, it can move around upwards of 100 pounds.
Yeah.
The only reason you know that is I wrote it for it.
Yeah, he rode it like a go-kart, so like programmable controller on his phone, and he sat inside a robot and he drove it around.
Anyone else?
Lift it up and put it in the...
There for like safety production.
There's the hand rating sensor.
What's the purpose of the blinking light?
So if it's flashing, that means the robot can move. It's for safety precautions. If it's not flashing, that means it can't move at all.
It's just filling numbers here.
First time we competed in competition. So we first competed in competition back in 2008. And yeah, so now it's been what, 7 years? Oh, big guy. Biggest competitor. So Texas is probably one of us, but they're also like one of our closest partners. So especially in Texas is probably the worst region to compete in. Because a lot of the best teams in the world are from Texas. such as Westwood,
Will have their robot built by NASA.
yeah, they have their robot built by NASA. NASA also like showcases their robot.
They have a workshop at NASA.
Yeah, at NASA. Like,
Well, Westlake mostly because they're just we have a healthy relationship or healthy rivalry.
yeah, and it's annoying because they're loaded and bad.
How many girls do you have in your robotics club?
That's okay. Last year that was closer. We had about 1 or 2 girls in our club last year. This year we have somewhere about a 35% female population and 6 girls. I'd say this year we at least can have used more than 2 hands to count all them.
Can you list your experience in robotics club when you apply for scholarships in college?
Actually, that's a great question. So the competition we competed, FRC, has a bunch of scholarships that only FRC members can compete for. So, and there's about they have a stat.
They take a meter. Only for Texas they have like a handful, but overall they have there's a website dedicated to it. There's upwards of 1,000 possible scholarships.
Yeah, and about 25 million or something like that goes to waste every year. People just don't apply. But if you want scholarships, you just have to apply to them, and you can easily get them. So there's a bunch of money that you can get, like you do in FRC for college.
Does the robot have a name?
Yeah.
Tetris, but
Yeah, I didn't think of the name. So don't blame me.
so the way Tetris, mostly because the way the boxes are laid out on the wheel, they're in a form that like they're like a puzzle. You have to get out different pieces. You have to get out pieces from the puzzle, and just move the boxes around, stack them up.
I'm just wondering, you kids know what Tetris is, right?
It's that.
I love Tetris. Yeah. Like kids that like Laurel Mountain had no idea what one more thing. If any of you are fifth graders, feel free to sign up right up there. We'll send you an email about what our meetings are. You don't have any obligation to come, but if you want to just come check us out, you can come by.
We have no summer meetings.
So during competition, okay, it's really based on competition, what part of the season it is. If it's during competition season, we're meeting every day, and you can come however long you want. If you're like him, you can come till 3 a.m.
Yes.
But if you're like the majority of people, you can come like 1 hour every week, or maybe 1 hour every other week. Or if you want to stay longer, you can come like 5 hours a day. It's really based off what you want.
And what your parents will do.
Yeah, mostly.
Yes.
Who are y'all sponsors?
Oh.
That board.
It's in the yellow one.
It's on my back.
That was in the yellow one.
Our sponsors are Redworks, Dell, Texas Workforce Commission, IBM, 3M, and DigiV.
Oh, okay, cool.
And we also get grants from other people, but those are our main
And
sponsors.
random anonymous donations.
Yeah, from people who drive by. Yep, that happened.
So how many robots do you have?
Built, working, we have 2 robots.
That are built and working. Then we have a bunch of robots just kind of lying around.
They're in our mentor's basement.
Yeah, they're all in this basement. And the only time we ever pull them out is when we have homecoming parades, because during the homecoming parade we have the basketball team robot just shoot basketballs.
The frisbee one doesn't exist anymore, but it used to shoot frisbees at people. And we have a yoga ball one that shoots large 2-foot yoga ball.
That was the last year's competition, the yoga ball one. So that 2-foot diameter yoga ball that it's a giant catapult and it's just launched the yoga ball.
To a 2.5-foot tall target.
Yes. That is the one we brought forward. Oh, okay. I thought you were reading.
Yes. No.
1 hour.
9 hours, but I call it
Yeah,
there's another.
competition. One time, like we were competing, and this robot is just like going really fast, and then all of a sudden you just start seeing smoke, and then it just stops.
Wasn't that last or NASA's robot?
Yeah, that was NASA's robot.
And that's the robot got fired.
They're all sad, but smiling at the same time.
You should.
If you're wondering what that sound is, that's the air compressor. And if you're wondering why we're using an air compressor, do you guys know what pneumatics is?
Anybody know what hydraulics are? Or heard of hydraulics?
Yeah.
So hydraulics use liquid, pneumatics use air. Compressed air. Yes, compressed air. We can't use pneumatics because there's a possibility that we can use hydraulics. We can't use hydraulics because it can leak around the field. Pneumatics just use air, so it leaks, you just have compressor running all the time. It's just annoying.
It's a lot easier to clean up air than it is water.
Yeah, we do.
What kind of software are you using to design these? What is your design process when you're coming up? Do you have certain rules for the competition?
Okay,
And
so that's a very good question, the design process of the robot. So the way we design it is so they have a massive event called the FRC Kickoff event, where all the teams in the local regions, such as Westlake, us, a bunch of other teams, we all go to, what's the mall? CrossFit Subway. It's the church.
Oh, Hill Country Path.
Bible church.
Oh, church, yes.
Yeah, we all go there.
That's
And,
where it's held.
yeah, and then they have a bunch, like a bunch of promotional videos, and then they reveal to us the competition. As soon as they reveal to us the competition, we go back to our workshop.
6 weeks.
Yeah, we have 6 weeks from that moment onwards, and we go back to the workshop and we start with brainstorming, where everyone thinks of an idea and pitches it in. As soon as we got some pretty good ideas, we do prototyping, where we just take a bunch of scrap like PC2 and wood, and we just use it to make like the basic parts, such as this cloth. We actually had to prototype it, so we had a hook, and when we tried it the first time, and we hooked that, it'd be like this, so it'd fall off immediately if with just a normal hook. So we realized if you put a weight on the bottom, then it'll pick it up like this.
Turn side.
Yeah. So you got a weight on the bottom.
Not a weight, but like back.
Yeah, back up. It would stop it from falling off, and because of prototyping, we figured that out. So that's the eventual design we use for this.
The software that we use is software.
And then we do something called CAD. Are any of you taking IED next year?
And we've taken our gateway this year and used Inventor. Right, so it's like Inventor, but it's a different type of CAD software.
So CAD, for those of you who don't know, is a modeling software. Yeah, it's computer aided design, but it's used to model all these parts on a computer. And so you can figure out their exact weights based on the material that you'd be using, their sizes, where the holes would be located. So you can coordinate all that information without having just like one drawing that everyone's passing around. After that, we've CAD'd everything, then we actually start cutting out parts and putting it together. And then we come up with something that looked like this. And then we completely redesigned it almost when we're testing it. And then we get this.
The only restrictions we have is that we can't use, unless the design we used last year was released to the public to see it, we can't use it. So anything you use this year has to be made brand new or has to be released before the kickoff of this year's event. Yeah.
Whose main idea was this?
Kind of collaborate. We don't really know who came up with bits and pieces anymore. Yeah.
So, like I assume pneumatic, your lifter design, you couldn't use exactly the same design for a lifter next year or something?
If we release it before the day of the kickoff, we can. If not, we have to.
Well, then it's released now, so you couldn't use it next year.
It's as long as it's publicly available before the kickoff. Anytime before.
Yeah, there's a lot of weird rules in there that you kind of have to work around. And there's a huge rule book we have to read every year. Or say you So we have 3 competitions. First one's best, which I know the painting is the team. Then we have first.
The kickoff starts on June 4th and ends around February 17th.
Yeah. And the competition we went to this year was the day before, or 2 days before spring break. So we went there, went to competition, came home and went to spring break. Yeah.
If your robot fails, do you have a backup robot?
No, you just fix it. Yeah. That's all you can do. You usually end up taking parts from your robot to fix the part that's broken. Like I just took parts from the light to fix that or whatever.
So another question back. But when you want to come try to lift these boxes with the robot, then sure, you can come by. Play with it. We used it. This year we went to San Antonio.
Nobody goes to Houston unless you already made it. Because if it's for you're not going to win unless you're NASA.
Yes.
Plus, it's not fair because the weekend before that regional, NASA has all the best teams, which they decide who's the best team and invite them down to NASA to practice.
Yeah. I like back in England.
They kind of have home field advantage, so to speak.
Pretty ridiculous, but so just to give you like an idea of how hard Houston Regional is. So in San Antonio Regional, the highest scoring team averaged 100 points per round, and that was 20 points higher than the second place team, which was Westlake. The top team at Houston scored about 140 per round. So it was.
Max score was what, 300?
Yeah, max score was like, yeah, they got the high score there too, 300.
Max score at San Antonio was about 140.
Yeah, something like that. They got like 3 times the score. It's ridiculous.
What did they do to get 300 points?
No idea.
No idea. We just,
Box is really.
Basically, this game is just you have to have speed.
so the people who won at our competition, they actually had a really clever design. So they had 2 robots connected by a wire, so it's considered 1 robot. But the first robot just sat next. So they have this dispenser system where you can put these totes in. That's how you get them onto the field.
Like a feeding station.
Yeah, a feeding station. So they had the first robot sit next to that feeding station, and they just keep feeding these boxes to it, so it'd make the tower immediately. As soon as that robot was finished, the other robot would come by, pick up the entire tower, and then bring it
Literally 2 feet.
Yeah.
Drop off the box.
Yeah, and they would just get 3 immediately. And it was them, Westlake, and like the 52nd team, like
52nd place team.
yeah, place team on a team.
The other thing about the competition is that usually it's not always you're the best and then you get picked for an alliance. It's sometimes they just need a robot that does absolutely nothing to keep it out of the way.
So what Westlake did was they wanted to get all these green containers. So the main way to get green containers is each team has 1, like each alliance, and so, or they have 3, I mean, but 1 per team. So there's an alliance system where there's 3 versus 3. Each person on that team has 1 green container, and there's 4 in the middle. So the team that was 52nd out of 62, Westlake went up to it and was like, hey, we have this part that we want you to use, and here's the code for it. Can you just attach it? They're like, okay. So they asked them to do that, and all they would do is in the beginning of every round, they'd move out, and these 2 arms would extend out of their robot. They'd pick up those green containers and move backwards.
And then they would just sit there.
Yeah, then they would just sit there. That's all they did. And yet they got the internationals because their 2 partners carried them.
It's funny because they almost failed the last round.
Yeah, that's the interesting thing about competition. The team that usually wins are the ones that can do the challenge really well, but you can still get the internationals if you just specialize your robot in one place that gets you a lot of points.
Have you guys ever used a 3D printer to model your parts?
Yes.
I know, isn't Westlake that uses 3D?
Yeah. Well, we used to use 3D printed parts until we found that we don't really need to make specialized parts. We do model them. We have 2 3D printers at our school at Westwood, and then we can use the large 3D printer at Dell, 2 of them. But we don't really use parts for them. Westlake does use parts, but they have to have lots of replacements so they break really. last year's robot. It fit about a quarter mile of wiring into base smaller than that. And we had to work with 4 very high tension springs that could snap and cut your head off. So very complicated, very safety hazard, but that was what my fun was.
One thing to note, we do have a lot of safety training.
Yes.
Because some of the stuff we use is very dangerous. Like, have any of you used the bandsaw?
Those are gateway and right.
Yeah.
Check out.
Yeah, I thought of elementary school was having these. I don't know about these stories. So for those of you who don't know, the bandsaws were originally used in butcher shops to cut cows in half. And now we use to cut metal and wood, with our hand next to it. So we have to train you so you keep all your body parts.
You're not allowed to work in the shop unless you know what you're doing. So every year we have, until everybody is safety trained, nobody's allowed to do any work. And you have to actually be signed off by one of our mentors.
Do you guys do chairmans?
Yes. So,
Again,
yes,
your position. Yeah.
You got second.
I did chairman's.
You memorized his entire speech.
I did memorize my speech.
Do it right now.
I don't know my speech. So chairman's is basically where you just say all the good things about your team and how you spread the first message to the community, because a lot of chairman's about community outreach and especially developing other teams or helping mentor teams to start them up. The last team I went with had started 7 teams.
Yeah, so what was it, Holy Cows? So there's a team called the Holy Cows. They won international chairmen
Because they had
2 years ago, and what they did was they started FRC teams all around California. So almost all the FRC teams in California, Los Angeles and San Francisco, I think, are all started by them.
So that's basically you just need to start teams and you have a good chance.
And mainly you win chairmen and just throw money at it. Eventually win. In school, no, we don't work. It's really based on the team structure. Our team does it purely as a club, so it's all an after-school activity.
We do somewhat work on it. There are people who don't have anything to do during school, which is really weird because it's Westwood. But since we can just take our laptops to class, we'll work on designs there. I'll work on programming for the robot constantly. Govan actually designed, I do remember he designed the base for it. He was always working on it. He was always working on designs. And we would, Etienne and our Vice President Lindsay would work on chairmans a lot. And we usually meet up during lunch to talk about what we've done, if we've done anything.
But but it's really based on school. So going back to Westlake, they run it as a sports team basically. So they do it almost entirely out of school. But we are totally different. And then also people like the Girl Scouts, who have lady cams, they do it as a Girl Scout activity. So it's all out of school. So it's just really based off what team you're part of. So if it's this team, you just do it after school.
We do it at buildings.
Yeah. If any of you know.
Yeah.
It's right down the street here.
Exactly.
Let's go. Where do you go?
Oh, it's.
Yeah.
It's important.
This location is very important.
So this is kind of a random question, but what were some problems that you had while designing that robot?
Space.
Yeah.
The way we designed it, one dimension has to be 28 inches to make it out the door. But the way that it was designed initially, this was supposed to be 28 inches, which doesn't help because we wanted to extend past that. And so we had to work on making it wider.
Yeah. There was also originally it was 122 pounds, so we had to cut that because the weight limit's 120. So we cut it down to 119.6 pounds.
By switching out these motors, I don't know if you can all see them, but these motors each weigh about 2.5 pounds. And altogether, we have 4 of them in the bottom of this. So we had to switch them out. We had 4-pound motors on here before.